So for ChatGPT, there is no scientific paper, but there is like a blog post which has this diagram. And also there is a model InstructGPT. It was predecessor of ChatGPT and has published papers. So we can get some intuition of how ChatGPT works from InstructGPT model. And it has pretty similar diagrams. So long story short, ChatGPT is a fine-tuned version of GPT 3.5 model, generative pre-training transformer. So there are a number of large language models. GPT is not the only one. For example, there are GPT, there is BERT from Google, and there are Elmo model. The GPT and BERT are most well known and based on the transformer networks. And here, each word is an embedding. There is basically a vocabulary for GPT. It's about 50,000 tokens. This is a vocabulary. So that means that before embedding, you have one hot encoded vector of size about 50,000. It's quite huge. Indicates ID of this word. ID 12,175 represents a word retro. But more complicated words, which is not so often, this pre-processing can split into, let's say, 4 words, like Kilimanjaro in Kilimanjaro, and each of them then will be represented as this one hot encoded vector of size about 50,000. But this one hot encoded vector is later encoded, like embedded into a smaller dimensional latent space, and those are embeddings that represent the input to this pre-trained transformer. So you have a sequence of such embeddings which represents the sentence. GPT model takes as an input a sequence of words called context and predicts a probability of the next word. Thus, each word in the vocabulary gets a probability value, and then the next word can be randomly sampled from that vocabulary, given the predicted probability for each word. GPT is an autoregressive language model, and it is trained to predict the next word from left to right. Here's an example from their paper, InstructGPT. Here's a text prompt, explains the moon landing to a 6-year-old in a few sentences. And then the completion of GPT-3 is just iteration of other questions, like in a questionnaire. Explain the theory of gravity to a 6-year-old, explain the theory of relativity to a 6-year-old in a few sentences, and so on. So that sounds like if you would ask, okay, is it coherent with the prompt? And probably the answer is yes, because there is some consistency between the prompt and the completion. But that's probably not what you expect from chat agent or from some search agent that can answer questions. And GPT-3 can be, in this case, a little bit useless, because if you want to focus that on some specific task, you need to fine-tune that. And there are several ways how to fine-tune. One way is to do just supervised learning. And that's what they did in this InstructGPT partially. So here's a collect demonstration data and train a supervised policy. So that means that you ask real people to generate input-output examples. So input as a prompt and output what should be as an output. And then just fine-tune that. I think it's supervised fine-tuning. Basically for 8,000K, you can already get some supervised dataset, which is already suitable to do some experiments, which is relatively low in comparison just how much it costs to train the model itself. So yeah, basically the process looks like that. In the first stage of supervised fine-tuning, like many people collecting prompt and completion examples, the model is fine-tuned. The second step, to train a reward model, or we can also call it like a value function. If we have, let's say, 4 different answers from a given prompt, because it's a probabilistic model, so for every given text prompt, you can generate many competitions. And then there are, again, human evaluators who decide which answer is the better. As you saw in this example, then as a human evaluator, you get the instruction, you get the output, and then you need to evaluate, is it good or is it bad? This is like a prompt, and then there's a variable article, and then there are outputs, like output A, summary 1, and then the person has to evaluate, is it not good, is it good? And then there are some binary questions, so inappropriate, some violent content, harmful advice, moral judgment. And this is used for outliers detectors. So namely, if for this particular summary, 10 people will have the same pattern of answering these questions, and 2 people will have slightly different pattern of answering these questions, that can be an indication that it's outliers, and they will be not used for ranking estimation of this summary. And this data is used to train a value function, or you can also call it like a critic in a reinforcement learning fashion, or they call it reward model. And with that, if we also collect several 100,000 such examples, we can train a reward model, because that can do basically also interpolation for similar cases, as you saw from this example. So this reward model will not be very precise, but it can estimate, is it like very good or is it very bad? And this smoothness is also helpful for assessment of new cases. So that's the second step, what they did in InstructGPT. And we assume ChatGPT is further fine-tuning or improvement of InstructGPT, which was published in 2022. So when we have this reward model, we can use kind of reinforcement learning here to further fine-tune the model to predict better answers. Now we have a text prompt as an input. Then this GPT 3.5 model outputs some answer. And then this reward model outputs some value about this answer. In this particular step, I just can guess. I don't have ground truth information. But what I can assume, so because it's neural network, that means that it can backpropagate gradient. And the simple trick that you can do that was even done, for example, for this network, you have here a value function, can work in the same way. So you have this state, you have this action, and that goes as an input to the critic network. And the critic network has like minus 30 value. So how to update weights of the policy network such that the output of the critic will be slightly higher? Here you need to keep in mind that we have two networks. First is critic. For the critic, it has an output, a single value, and you want to increase this value, so you do gradient ascent, and this backpropagated to the actions, which are the input to this critical network. But this action is also output of the policy network. So with backpropagation, you know, okay, if you move, let's say, these actions slightly up and this action slightly down, then the output value of the critic will increase, and that's what we need. Then for the actor policy, we already have an objective that, okay, this value has to go down and this value has to go up. And that's the weights of the policy network then are being updated for this particular state input. I assume that a similar logic is applicable also here, that we have an estimation by the reward model, what is the value of this answer, so that we can say, okay, we want to have a higher value. And in order to have a high value, we can do backpropagation, and then at the input of this reward model, we know which probabilities should be increased, which probabilities should be decreased. And this information can help to update the weights of the GPT 3.5 model. That's basically similar to what we have here, but this is just increase the amount of assessments that it's possible to do, because here for each assessment you need to pay, and therefore the number of assessments is limited. But if we have a good interpolation model of the reward model, then it's possible to do 1,000 times more examples of this assessment, and in the next stage, fine-tune the GPT-3 model. In general, this is GPT-3 model which is fine-tuned several times, and therefore you can also think about that not like a self-conscious. It's more like a fine-tuned supervised learning model. You have some certain functionalities that you want to get from the ChatGPT, for example, or similar model. You get a lot of demonstrations data from constructors, labels like examples of correct answers. And then you make another iteration with, in this case, with a value function to make this fine-tuning for much more examples. Okay, ChatGPT has the functionality it's possible to evaluate the response. Is it good or is it bad? So I think it has dozens of millions of users, the ChatGPT right now, but not sure about how many of them actually provide some feedback. But even if 10% provides some feedback and does it 10 times per some amount of time, it's already a lot of data to fine-tune the, for example, in this case, reward model. Maybe I can give some slightly different point of view on this reward model. So it's somehow similar to generative adversarial networks, where you have a discriminator to train a generator. So this reward model is kind of a discriminator that is being used to fine-tune the outputs of the GPT 3.5 model.